So we are going to get started with our ideal gas law equation by first analyzing all of the variables that are part of it. So we have the equation PV equals nRT. P stands for pressure, V for volume, N for the number of moles, R is a new introduction that we have for the gas constant, and T is going to be for the temperature. So we are going to go through the ones that require additional information that we need to go over. So we're going to get started with temperature. So in temperature, we are aware that it can be measured in different units. And particularly for the ideal gas law, we need to look at temperature being measured in Kelvin. So sometimes what you will see and you will encounter on the questions will be that the temperature was measured in Celsius. So we just need to make a quick conversion between the two. So what we have here on the slide is on this red box, we have the equation that we need to use. So for example, if we are given the value for Celsius as, 20 degrees Celsius. Well, all you need to do is to get Kelvin is going to be adding 20 and 273. That is a conversion factor that we're going to use. So our Kelvin used in the equation is going to end up being 293. And just as a recap for temperature, temperature is the measurement of the kinetic energy, the average kinetic energy of a particular gas. So it's basically taking all of the energy that the particles have that compose a gas and taking their average kinetic energy. So that's what we have temperature. And we need to make sure that we are using the calculation. In the calculation, we need to use Kelvin. So for pressure, you will note here at the bottom that there's a lot of different ways that we can calculate or that we can measure pressure. But we don't have to learn those conversions. We just really need to know when to use what. So for pressure is the interaction or the measurement of the force that all of the particles are exerting or they're applying on the walls of a container that our gas is in. And that could go anything from a can of aerosol, or it can be to like the tire in the car. What we're talking about here is that the particles that compose the gas are moving and they are colliding with the walls of whatever container they're in. So depending on how fast they're moving and how many collisions are happening at any given point in time, the amount of force that is being applied on the container is going to be different. And that force is going to be the pressure. So what we need to know and understand here is that it can be measured in a lot of different units, and that whenever we do not know what the pressure is, and we must use a pressure at some point, we are going to measure it in atmospheres. So that's something important that we need to know. So what about that R that is in the equation? So what that is going to be a constant. That constant is going to be completely dependent on the pressure. So it's important in our equations to know what pressure is. And remember, if you don't know what it is, you're not told what that value, what that unit is, assume it's atmospheres. So again, the ideal gas constant is going to be dependent on the pressure, the unit of the pressure that is used. So you can see here that, for example, if the question doesn't tell you what pressure is, or it does tell you that it's atmospheres, then in your calculation, you need to use 0.0821. If the question or the problem gives you mmHg, which is torr, we are going to use 62.4. If we are told that the unit of measurement for pressure is kilopascals, then we're going to use the constant for 8.31. So we need to keep all of that information in mind. The last thing I will say in terms of the ideal gas equation is in regards to volume. Volume, we need to make sure that when we are using a calculation, the unit is going to be in liters. So if something doesn't say liters, let's say milliliters, you need to make sure that you convert from milliliters into liters. So just as a quick recap, pressure, well, that will depend, right? We have many ways, but if we're not told what it is, we assume that it is atmosphere. For N on the equation, that's going to be the moles. R is going to be completely dependent on whatever pressure is. And remember, that could be a lot of different things. So we just need to be careful that we are reading the equation, the problem properly so that we can identify that. Kilopascals. And then for temperature, we need to make sure that temperature is measured in Kelvin. With that basic knowledge, we can go ahead and look at an example. So on this example, we have a deep underground cavern contains 2 liters of methane gas at a pressure of 1,500 kilopascals and a temperature of 23 degrees Celsius. And the question is, how many moles of methane gas are inside of the cavern? So the first thing I want us to do is highlight all of our values and find the information, some of our resources that we need available. So what we're going to do here is go one by one in the equation for PV equals nRT and start adding that information in. So the first value that we have is pressure. And here the pressure is 1,500 kilopascals. So I'll just go ahead and input that into my rewriting of the equation. 1,500 kilopascals. The next part of our equation is volume. So here the question tells us that we have volume, and that is 2 liters. We have equal sign, and then we have N, which is a moles, which is exactly what we're looking for, so we just write N for moles. And I'm putting everything in parentheses just because I want to make sure that when I input it into a calculator, everything is good, and the calculator won't get confused. So then we have R, the next part of the equation. And for R, remember, is dependent on whatever that pressure is. So pressure here was in kilopascals. So out of the 3 different constants for R, we are going to use the one that has kilopascals. So that would be this number right here. So that's what we are going to input into our calculation. So 8.31 kilopascals. The last part of our ideal gas example equation is going to be temperature. So we make sure temperature is always in Kelvin. So we need to make sure it's in Kelvin. And here the problem gives us 23 degrees Celsius. So all I'm going to do for that is going to be 23 plus 273, and that's going to give me 296. So that's the number I'm going to input into my equation. So 296. And that is in Kelvin. So now that I have all of my values, I can use my algebraic knowledge and solve for my missing variable. So I will input here in the video how it is that we're going to calculate this on the calculator. So in other words, all you would have to do is multiply the left side, multiply the right side, and make sure that we are dividing it properly. So it's very useful at this point to use parentheses on every single thing that you have here. So anyway, our answer for this problem comes out to be 1.2196 moles of methane gas, which is what's available in the cavern. So what you guys see here are some practice problems that I want you guys to work through. We will have the answers posted for these 3 practice questions at the very, very, very end of the video. So make sure that you go through and compare your answers with those that are posted.